pleasant day, everyone. Today we will know the fundamental trigonometric identities and how to use them in simplifying trigonometric expressions. So we have here first the reciprocal identities. So as you can see, we have here the cosecant theta is equal to 1 over sine theta. Or it can be also its reciprocal, which is sine theta is equal to 1 over cosecant theta. Another is the secant theta is equal to 1 over cosine theta, and its reciprocal is cosine theta is equal to 1 over secant theta. Last is we have cotangent theta is equal to 1 over tangent theta, or it could also be tangent theta is equal to 1 over cotangent theta. So that's the reciprocal identities. Now, let's have the quotient identities. So in quotient identities, these two, the tangent theta and the cotangent theta, is the most common or the most common quotient identity used in a trigonometric expression. So the tangent theta here is equal to sine theta over cosine theta, and our cotangent theta is equal to cosine theta over sine theta. So that's our quotient identities. While in our Pythagorean identities, we have here sine squared theta plus cosine squared theta is equal to 1. And if we want to transfer the cosine squared theta to the right side, then the expression goes on like this. Sine theta, sine theta squared is equal to 1 minus cosine squared theta. Or it is also the same with cosine squared theta is equal to 1 minus sine squared theta. So that's the first Pythagorean identity. Next, we have here the tangent squared theta plus 1 is equal to secant squared theta. Or you could also use, it's the same with tangent squared theta is equal to secant squared theta minus 1. Or 1 is equal to secant squared theta minus tangent theta squared. So that's the second. And last, we have here 1 plus cotangent squared theta is equal to cosecant squared theta. Or you could also use cotangent squared theta is equal to cosecant squared theta minus 1, or 1 is equal to cosecant squared theta minus cotangent squared theta. So that's our Pythagorean identities. And lastly, we have here our product identities. So in product identities, the tangent theta is equals to secant theta times sine theta, while the sine theta is equal to tangent theta times cosine theta, and we have here the cosine theta is equal to sine theta times cotangent theta, and our cotangent theta is equals to cosecant theta times cosine theta, while our cosecant theta is equal to secant theta times cotangent theta, and our secant theta is equal to tangent theta times cosecant theta. So these trigonometric identities is these identities we can use in simplifying trigonometric expressions. So now let's proceed with our examples, and we will use these identities in simplifying these expressions. So for our first example, we have here tangent theta times cosine theta over sine theta. So in simplifying a trigonometric expressions, the first thing you need to do is to examine the expressions, and you need to simplify it. So the first thing you need to do is to rewrite all the function in term of sine and cosine, meaning that this tangent here, we need to use the fundamental identity for us to write the term in sine and cosine. So we need to use the fundamental identity for us to rewrite in terms of sine and cosine. So by applying the quotient identities, we know that tangent theta here, tangent theta is equivalent or same with sine theta over cosine theta. So what we will do next is we will just copy the, so we have here the equivalent of tangent theta, and we will just copy the cosine theta over sine theta. And then now we can see that we can cancel this cosine theta, so we cancel them, and this is equal to 1. So the expression will become like this: sine theta over 1 over sine theta. So it doesn't stop here, we still need to simplify it. So in simplifying this one, we will just multiply it, we will just multiply this one with the reciprocal of the denominator, the reciprocal of sine theta. So the reciprocal of this one is 1 over sine theta. So now we can cancel the sine theta, cancel it. So this will become 1 over 1 or positive 1. So the answer is 1 over 1 or positive 1. So that's the first example. Now let's proceed to the second example. For our second example, we have here cosecant squared theta plus cosecant squared theta times tan squared theta. So this trigonometric expression is very familiar since we have this one is a Pythagorean, right? Pythagorean identity. So in this expression, we can see that there are two common terms. So we have here these two are common terms. So what we will do is we will factor out this one, these two. I mean, so this will become the first term will become 1. So the expression goes on like this: squared theta 1 plus tangent squared theta. So what we will do next is this tangent here. We will apply the Pythagorean identities, which is tangent theta is equivalent to this one is equivalent to secant squared theta. So this will become like this: cosine squared, we will just copy that one, theta, and this one will become secant squared theta. Okay, for us to simplify this one, we will use the reciprocal identity. So secant is, what is the reciprocal of secant? So secant is 1 over cos theta squared. So now we can we'll just copy this one, okay, here. So we can now cancel this one, cancel this one, cancel this one. So we have here 1 over 1 or 1. Therefore the simplified expression of this trigonometric expression is equivalent to 1. So that's our second example. Now let's proceed with our third example. So for our third example, we have here cotangent theta times tangent theta plus cotangent theta. So what we will do is we will distribute this cotangent here, distribute it here, and then it will become like this: cotangent theta times cotangent theta tangent theta times tangent theta plus this 2 will become cotangent squared theta. So there you go. Now next thing we need to do is to apply um, the identity with this 2, which is the quotient identity. In quotient identity, the cotangent theta is equivalent to cosine theta over sine theta, and then this way, that is multiplication times tangent theta is equivalent to sine theta over cosine theta. Now what we will do next is we will copy the remaining cotangent squared theta, and then we will cancel out this and cancel. So this will become 1, equal to 1 plus copy cotangent squared theta. Well, this one is very familiar, right? Because this is a Pythagorean identity. So this is equivalent to cosecant squared theta. Therefore, the original expression can be reduced as cosecant theta squared. So this is the the original expression can be reduced to cosecant squared theta. Now for our last example, okay, for our last example, we have here secant squared theta times 1 minus sine squared theta. So we will first, this expression is very familiar because this is a Pythagorean identity. So we will replace this one, which is, it could also be expressed like is this could also be expressed as sine squared theta plus cosine squared theta, or cosine squared theta. Um, Cosine squared theta is also equivalent to 1 minus sine squared theta, but we will just use this one. Okay, now we will just copy. Okay, this one is equivalent to this one. No, the one here is, we will just substitute it with this Pythagorean expression. So we will just copy the remaining parts, and then we have here our 1 becomes sine squared theta plus cosine squared theta, and our sine minus sine squared theta. So that's our expression. Now this one, oh yeah, sorry, we can cancel this one, so what remains is secant squared theta and our cosine squared theta. So that's it. Now for us to simplify it, we will find its we will use the reciprocal of secant, which is secant is equivalent to 1 over cosine squared theta, and we will multiply it with the reciprocal of the cosine squared theta, which is cosine squared theta over 1. So now we can cancel out this one, and the remain, and the simplified expression is 1. So that's it for our last example. Hope you have learned something out of our video this morning. Good day, everyone.